Hello everyone. Today we are going to learn 8.2 hypothesis testing proportions. So we learned about logic of hypothesis test last section, right? So today we talk about hypothesis testing proportions. Okay, so let us take a look the learning objective here, right? Okay, so we learned about this one last time. So let me read one more time. So how do we make a logic of hypothesis testing? We do identify null hypothesis test. We called H naught, right? And alternative hypothesis test H sub A, right? So null hypothesis test always equal to, right? Then alternative hypothesis test is against to the null hypothesis test. So it should be not equal to or less than or greater than. So that against the null hypothesis test, right? Okay, now identify or decide the level of significance alpha. So it will be given, but sometimes they don't give us. Then we say that if alpha is unknown, so let me write down. Alpha is given, but but when alpha is not given, we assume that alpha equal to 0.05. So we talk about the unusual, right? So probability is unusual when the probability is less than 0.05, which is 5%. That's why if alpha is unknown, then we are using the unusual part, which is 0.05, which is 5%. Yeah. Okay. Now, identify the sampling distribution and verify that all required conditions for the test are met. So sampling distribution, we have what? Let me think. Yeah, so the sampling distribution means the p hat equal to p, population proportion, right? Sigma sub p hat equal to square root p times 1 minus p over n, right? Yeah. And then sample size. Sample size must be big enough. So how much? N times p times 1 minus p must be greater than or equal to 10. Then we can say that this is a normal distribution. Why we need this one? In order to use StatCrunch normal distribution. Yeah. Okay. Now use the sample data to compute test statistics. So this is brand new terminology. We're going to talk about that later. And then find the p-value. And then p-value is less than alpha. We do reject the null hypothesis test. If the p-value is not less than alpha, we do not reject the null hypothesis test or fail to reject the null hypothesis test. So we talk about this like a court system. We don't say the innocent, right? We say the guilty, not guilty. So here, p-value is less than alpha. We say that reject or fail. Oh no, p-value is greater than alpha, fail to reject. Yeah, p-value is less than alpha. We do reject the null hypothesis test. Okay, so why why we reject? Because we take the p-value. So we assume that null hypothesis is true. But then p-value is unusual. If, okay, let me write that. And then read. Okay, so I just wrote down here. We assume that the null hypothesis test is true, right? We start with, then we gathering all the sample proportion or sample mean. In that case, the sample proportion. So this section is about the sample proportions, right? So the p-value is less than alpha, means that alpha is the level of significance. So it will be given, it could be 10% or 5% or 1% or 3%. Then under the null hypothesis is true, right? But then we get the p-value, which is tail probability. It can be left tail or right tail or two tail, right? So those probability is less than alpha, means unusual, tiny number, right? So it's impossible to have those probability. Like we win the lottery, it's unusual, right? Very unlikely to have that, right? To happen, right? That's why we say that reject the null hypothesis, the null hypothesis test. Make sense? Okay. So let's remember only one thing. If p-value is less than alpha, we do reject the null hypothesis test, otherwise fail to reject. Yeah, means that p is greater than alpha. Yeah. Okay. So let us take a look. Hypothesis testing proportions. Yeah. Okay. So I say that. We say that. We say that, right? Okay. So test statistic here, new terminology. So I'm going to call the z-test statistic because we are going to learn t-test statistic later, okay? So in that case, z-test statistic. All right, so z-test statistic is a z-score, but it's a special z-score, okay? So z-test statistic is a specific type of z-score used to when testing hypothesis T about population mean or proportions. In that case, in this section, we are talking about the proportions. Okay. All right. And what is it for then? Test statistic measures how far the sample statistic. So sample statistic means it can be X4 or sample proportion. So sample mean or sample proportion is from the hypothesis population parameter under the null hypothesis test. Yeah. Okay. So we have left tail test. And then we have right tail test. And then we have a two tail test. Yeah. Okay. So we indicate that left tail test, like inequality. Yeah. Because it's the left side, right? And right side, right tail test. Then we're using two tail test, not equal to. All right. So do you understand what we are doing? Okay, very good. Okay, so let's do this example. We have the null hypothesis test, population proportion equal to 0.48. And the alternative hypothesis test is P is less than 0.48. Simple random sample size n equal to 144 has 64 successes, right? Okay, they said assume that simple random sample follow the conditions for binomial experiment, follow 6-step process to complete hypothesis test. Ready? Okay, so step one, we have to identify the null and alternative hypothesis test, right? There we go, there is. Just copy paste, right? So this is the one. Then we need to determine whether left tail, right tail, two tail, right? What do you think? So this inequality, like left side, right? So the population proportion is the left side, so left tail. That's how I remember. So left tail test. Okay, so significance level alpha, I told you is almost every time will be given, right? So alpha in the case 0.05. So alpha equal to 0.05 is given. If not, we can just say that alpha equal to 0.05. Yeah. All right. Step 3. Uh, Simple random sample size, right? And binomial experiment are met. So they already said it met, right? And we have to check their sample size. Means that it's a sample size big enough so that the distribution become normal, right? So let's check that. N times P, we have N. N equal to 144. So let me write down N equal to 144, P equal to 0.48, right? Okay, so N times P, so 144 times 0.48 and 1 minus P, which is 0.48. Can you please calculate? 35.9424, which is greater than or equal to 10. So it's a normal distribution, right? So it's normal. Why we need this? We need this in order to use StatCrunch normal distribution to find out the probability, right? Okay, now this is step 4. So after normal, we have to check test statistics. So test statistic is Z-score, right? But all Z-score is not test statistic, right? So test statistic is Z-score, but Z-score is not test statistic, right? Some Z-score is test statistic. Make sense to you? Yeah. Okay. Yeah, it's like the squares. We can say that all squares is rectangles, but we don't say that all rectangles is square, right? So square is rectangles, but rectangles is not square. Okay, so same as here, Z-score is not test statistic, but test statistic is Z-scores. Make sense? Okay, so let us do this. Uh, oh, did I say that right? Uh, we had a Z-score. So that is x minus sigma, sorry, sigma, mu, x minus mu over sigma, right? Yeah, then it's the same formula, right? So what's the x? So in that case, we are using proportion. So sample proportion minus what's the mu? Mu sub p hat, which is a p, right? Over what's the sigma? Sigma sub p hat, right? Basically same formula. All right. Okay. Because test statistic is z-score. All right. But then p hat, let's use p hat first, x over n. So x in the case, how many successes there? It's no, 64. Can you see the 64? And then 144 is the n. 64 out of 144. You have to calculate, please. All right. So 0.444444. Okay. Now, what is the sigma sub p hat? So square root p 1 minus p over n square root p, which is 0.48, 1 minus p, which is 0.48, and divided by n, which is 144, right? Can you please calculate? Yeah, it's a 0.041633, 0.041633. Yeah, I want to keep the decimal as much as I can so that we can round at the end. All right, so what's the test, z-test statistic? So p hat minus p over sigma sub p hat. So there will be p hat, which is 0.444 minus p, which is 0.48 over sigma sub p hat, which is 0.041633. What do you get? Negative 0.8551. Yeah. Okay. Step 5. We want to compute p-value. Yeah. So this is the left tail test, right? All right. So what we do? So test statistic is z-score, so we can interpret the sample proportion. We have a negative, so this is a distance, right? So 0.8551 standard deviation below the mean, right? Because it's negative, it's below standard. Okay, let me talk. Z-score is distance in terms of standard deviation, right? So we called 0.8551 is distance in terms of standard deviation. So we say that below the standard deviation because negative, right? If we don't have a negative, it's positive, we say that above the mean, right? So standard deviation above the mean, right? So this is below the mean because mean equal to 0. Make sense? Okay, so we did that before. All right, then we are going to use StatCrunch. There is a two-way. So is there? Okay, so StatCrunch. Look, when we use z-score, for z-score, we were using mu equal to 0, sigma equal to 1. Then in that case, z-test statistic, right? Let me denote it like that. It's the same as z-score. So that is negative 0.8551. There is one way, right? Another way, how do you do? mean we are using mu sub p hat. That is a p, right? In that case, p is 0.48. Then standard deviation, let me denote the standard deviation like that. So standard deviation is sigma sub p hat. So sigma sub p hat square root p 1 minus p over n, which is in the case we had 0.041633, right? So we did that this one in the section 7.4, right? In sampling distribution of sample proportion, right? Okay, so we are using that. Then we're just looking at the probability. So that x will be in the case it's not x, right? So there will be p hat, right? So we are using that. So in that case, we are using p, which is z square with this number, right? Is it clear to you? So p hat in that case, what we have, p hat 0.444. Yeah. So there is a two way we can use a stack count. One is for z score, one is for p hat. Yeah. This let's say that this is for p hat. One is z score or for p hat. How about that? So there is a two way. Make sense to you? I'm gonna show you both. Let me take a picture and then I'm gonna show you both. So I need a z-tested statistic, which is z-score for the method 1. For method 2, I need that detail, right? Okay. All right. So we have to conclude whether we do reject or do not reject the null hypothesis test, right? So p-value, this is the p-value, which is 0.1962. So p-value, which is 0.1962. We compare with the alpha, which is 0.05, right? Then it's greater, right? So we do not reject. Do not reject the null hypothesis test. Let me denote the null hypothesis test like H naught, H sub 0, right? Why? Because there is insufficient evidence to support the alternative hypothesis test. Let me denote alternative hypothesis test H sub A, right? Okay, so p-value, I told you, assume under the null hypothesis test, right? Then we have to have unlikely, unusual, right? So that's impossible to have a p-value, which is the tail probability, right? Yeah. Then we do reject the null hypothesis test. Otherwise, do not reject the null hypothesis test. Why? Because there is no sufficient evidence to support the alternative hypothesis test. Yeah, means that we do all the sample proportion, right? We don't get that. Yeah, we don't get less than the point two, no, 0.48. So we don't get those kind of, it's less than, right? The alternative hypothesis test, right? So the sample proportion is around 48%, 50%, 53%, 45%, or 43%, right? We don't get 30%, we don't get 20%, we don't get the 25%. Yeah, that's why we say that there is no strong evidence, insufficient evidence to support the alternative hypothesis test. Make sense? Yeah, let me write that for you. Okay, so I wrote down here, means that we do sample proportion, but all sample proportion have 48%, 43%, 50%, 45%, etc. That's why they got 48%, right? Not like 30%, 28%, 25%. That is less than, right? Clear? Okay. Okay, so let's take a look at these questions. We have null hypothesis test is 0.72 and alternative hypothesis P is not 0.72, right? So that means two-tailed test, right? Okay, so let me take a picture of all the information. So we have 438 successes, and then the sample size is 576. All right, so what is called that? It's not equal to, that means a two-tailed test. Two-tailed test is a little bit more work, right? So what I do, I'm gonna use different software. I mean, it's the same StatCrunch, but different feature. Yeah. So let me take a picture and then let's go to the StatCrunch, everything. Okay. Okay, so let us do this example, real example, because it was given earlier, or the null hypothesis test and the alternative hypothesis test, right? So we have to set it up in the case. Okay, let's take a look. Let's read 38.4% of US households own a dog. A small dog-friendly towns city council believes their town has a greater proportion of dog owners. They collect a sample of n equal to 2,482 residents with 993 that own dogs. Can the city council conclude that their town has more dog owners than US average? Use 0.05 significance level, right? Okay, that means alpha equal to 0.05. Okay, this means P equal to Beyonce method, right? 0.01 times 0.01 or divide by 100. So 1 to the left, to the left, to the left, right? So 0.384. Yeah. Okay. Now, that will be success. X equal to success, and then that will be n equal to 2,482, right? Okay. Now, step one. What is the null hypothesis test? The parameter equal to the value, right? So in that case, proportion, population proportion equal to, always equal to in the null, right? So 0.384. What is the alternative hypothesis? We have the same parameter and same value. Now, how do we determine the against? With the equal, right? So is it less than, is it greater than, or not equal to, right? Different. Okay, let's read. Has more, that means it's greater. Ooh, what's going on? Has more, just has more. So greater, right? So we are using greater. Okay, step 2, alpha, level of significance. So there's alpha equal to 0.05. Step 3, what's about step 3? Okay, so let me copy all the binomial experiment math, right? And then we have to check that sample size in order to use normal, right? Yeah. Okay, so let's do this. N times P. So N equal to 2,482 times P, 0.384 times 1 minus 0.384. Can you please calculate? It's 587.1, which is greater than or equal to 10. So it's a normal distribution, yeah? So it's a normal distribution. Yeah, so we are using different feature, but still we check the probability, tail probability about the normal distribution, right? So we must check that big enough sample size in order to be normal distribution, okay? Now we are using StatCrunch. Let me take a picture of all the information. Look, I need X, I need N, I need the null and alternative hypothesis test, and I need alpha, right? Those information I'm gonna input the StatCrunch, yeah? Okay, so what if we have a data? So earlier we did that stack calculator, did we? Proportion with the summary, right? But what if we have data? So they say that here we need a copy, right? So data. Okay, let us do this one. Before we do that, we have to check that the null hypothesis test and the alternative hypothesis test, right? Okay, so we can see that 78% that is P, which is 0.78, right? So 1, 2. All right, so step 1, the null hypothesis test, the population proportion, which is 0.78, right? And then we have, they say the test, the hypothesis that the rate of vaccination was significantly lower in December, right? So lower, that means less than, right? This is less than. Okay, then alpha equal to 0.05, right? Okay, now alternative hypothesis, we have to write down same P and same value, and then lower, that means less than. Yeah, we are using that. Okay, let's go to the StatCrunch. We make a copy that data set and then copy paste in the StatCrunch. Oh, I need take a picture.